within the University of Mohammed VI Polytechnic in Morocco, and it's a big pleasure for me to give you a talk today about mineral production, environment, and circular economy, new horizons. So the talk of today is going to be divided into 5 main parts. The first part is about the challenges of the mining industry, and mainly in terms of the management of waste rock, tailings, and all the wastes that are generated by the mining industry. And then I will talk about the circular economy. What does it mean, circular economy, within the mining context? And what are the valorization pathways? I will talk about some case studies in Morocco about circular economy and how to valorize mine waste. And then I will give some a hint into some startups and companies that exist in the world that dealing with circular economy in the mining industry, and I will conclude with some discussions. So, as you know, currently in the mining industry, what we are doing right now is producing those critical minerals and metals and so on. And with the green energy transition, we will need more metals and more minerals. Yeah? And with this, we should not forget that a huge amount of wastes will also be generated. And as you see on this screen and on this slide, there are different types of wastes. We talk about waste rock, tailings, slags, and many other waste streams. And all those wastes are not considered almost in the circularity discussions and so on. And here, the idea here is to see this amount of waste that will be generated in the next few years. By 2050, we will generate like hundreds of billions of tons of waste annually. And that's so much materials that we will have to deal with. So now there are a lot of management methods and tailings management methods. I will not go into them all, but we talk mainly about reprocessing of waste rock. We talk about reprocessing of tailings. Why? Because we are looking for some other remaining minerals and metals inside, and we try to recover them and to valorize those wastes. We talk about in situ recovery, like instead of going into the mine and to extract all the material, we go with some kind of in situ leaching, and we produce those metals in order to reduce the amount of waste and tailings that are generated. We talk currently and recently about ore sand production. So you produce your metals, you produce your minerals, but at the same time you can produce a sand that can be used in other sectors, not only within the mining sector, but also in many other companies. We talk about tailings. When we talk about tailings, we talk mostly about dams failure, about this kind of rupture of tailings dams, and many catastrophic issues related to that in many different countries, in Brazil, United States, and many other countries. You can look for them. There is another problem is with the sulfur, the presence of sulfur in those tailings, which leads to the generation of acids, or what we call the acid mine drainage. And this is a real problem. And now companies are trying to go into those tailings and to try to recover that sulfur, to remove it from those tailings, so they can be like inert, and they will not generate this acid from those tailings. And there are a lot of work in that. And we have other techniques that tries to reduce or to increase the particle size of those tailings so we can use them outside and so on. So when we go into those tailings, what we do mainly is looking for a metal or a mineral or 2-3 metals that are existent in those minerals. But what we forgot is that if we look, for instance, for copper, all those metals are also present in the same deposit. And we recover only copper, but all those metals finish in the waste rock or in the tailings. And this is like a waste. of metals that are already in the deposit, but we do not extract them. We put them in the waste. We put them in the tailings, and that's just a waste of metals. And same thing for all the other things. Like for gold, you can have silver, copper, zinc, and all those metals are like critical and strategic minerals for so many countries. The other thing is when we talk about mining industry, we talk about a huge amount of waste rock that are generated. But if you go at the same time to the construction and the building sector, what we are doing right now is to consume a huge amount of materials in terms of aggregates, sand, gravel, crushed rocks, limestone, and so on. And all these, we currently consume around 20 to 30 billion tons of those materials per year by the construction sector. And by 2060, this is going to be the double of what we are consuming right now. And now, with all this happening, we talk about circularity and how the circular economy can lead into making the mining as sustainable as we can. And with circular economy, the principles, the idea is you have your raw material, and then it goes into the processing and so on, and then at the end you got some waste in terms of energy, water, emissions, landfill, and so on. When we talk about circular economy and generally, we try to minimize the amount of materials that are extracted, but also at the same time we try to minimize as a maximum possible the amount and the impact of this whole system. And it has like three main pillars to design the waste and pollution. And when we talk about design the waste, it's like to try to think a waste as a material and to design it. Because a waste is a failure of imagination. This is really the main problem here. A waste is a failure of imagination. Because of our failure of imagination, we produce that waste. But if we are innovative and we can take that waste and to design it in another way so it can be consumed at the end, it's not going to be a waste. It's going to be a material that can be consumed by other sectors. And this is really the main principle of the circular economy, is to design the waste and to keep the products and the materials in use at their highest utility by going towards reusing, recycling, but mainly avoid downcycling and so on. If we take the mining industry, and here we got like the whole value chain, from mapping, exploration, mining, processing, refining, and so on. And once you will get the raw material over here, or the metal, we process it so we can get kind of our phones, our like laptops, and so on. And the problem is that the majority of the waste that is produced in the whole life cycle of this supply chain is in this first steps of mining and processing and exploration, and in the form of waste rock and so on. If we go into the efforts that we are putting in to develop circularity in the mining industry, 99% of our efforts are mainly at this level, like at the downstream of the supply chain, but not in the upstream. 99%. So like 99% of the materials that are extracted are not concerned by the current circularity initiatives. And only 1% of circularity efforts are at this level. And this is really a big problem. And this is why here I'm trying to say that we have to change our focus from this place into this place, or to work on them all at the same time, because the amount of material that are produced at this level are just big. So we have this kind of waste management hierarchy that you can see here, where the most favored option is really to go into prevention, like to design the waste, and to minimize it, reuse it, recycle it, and the last, the option that we have to avoid is the disposal. So in terms of valorization pathways, we have many valorization pathways that we can consider. If we go into the construction sector, as I said before, we currently consume a lot of materials. And we from those mine waste, we can produce those kind of aggregates, like sand, aggregates, gravel, and so on. They are there already. We have just to think that those materials can be aggregates, can be sand, can be used as a gravel or something like that. We can build, can create our infrastructure, our buildings, and so on. We can use mine waste to do so. Just let's change our thinking and our mindset to do so. Cement and additives. You know now, currently we are consuming like around 4 billion tons of cement currently, mainly manufactured from limestone, clays, and some additives, iron, and so on. And this is really a very important material. And here, with mine waste, we can go just over here into those materials, and we can substitute a part or the totality of those materials by mine waste, and it's possible, and we have proven that so many times. We can build our bricks also with mine waste. There are some kind of knowledge that we'll have to know to do so, but it's possible. This is really the main idea. And now I will go into some case studies in Morocco that we have developed ourselves. And here, the first example is about the phosphate mining industry. If you go to the phosphate mining industry, we have different waste streams that are produced, like waste rock, damps, destoning, screening, tailings, and so on, and phosphogypsum. And all those waste streams are produced in hundreds of millions or billions of tons per year in the world. Just a huge, really huge amount of waste. And if we go into the volume of those materials, the main part is really in the form of waste rock. This is where we have really a lot of waste. It goes into the waste rock. But all the other streams are small, but not that small. We are talking about hundreds of millions of tons if we take the global scale. And for that, we, as researchers in the university, we said, OK, if we want to deal with those wastes, are we better to go into the downstream or to the upstream? Are we going to go into the current supply chain or to the current processing methods and try to redesign the processing methods so we can design those wastes? Or we can go into the downstream, into those already disposed waste rock and tailings, and to try to find solutions to valorize them. Here it's an example in Morocco of like a phosphate mining company where we talk about those waste rock. This is really the footprint of a small mining company, and it's something that exists in many different areas in the world also, not only in phosphate with coal and so many other commodities. And here you can see the tailings, and you can see the footprint that those waste rock or tailings can occupy in the space. And all these, if we want to go to deal with this kind of materials, it's really complicated. Why? Because everything is mixed up, and everything is it's very heterogeneous. And if you want to valorize these things, it's going to be complicated a little bit. But if you go into the downstream, or to the downstream into your deposit here, because here, what do you have? This is the deposit of phosphate. And what you can see in the yellow colors are all the other materials that are not phosphate, but finishes in these places here, in the waste rock. So the idea here is, why not going into the deposit and try to change our way of doing things and to extract selectively some layers and to do something with. And in the case of phosphate, in Morocco, those underburden and overburden materials are mainly in the form of limestone, clays, marls, and so on. And all those materials can be used in so many different applications. So what we have done is like, OK, let's go into the deposit and let's understand the whole deposit. Why? What is the composition of this deposit? What are the different layers? And what is the quantity of each layer and each material? What are its composition? And what are its characteristics? So with these informations, once it's gathered in a model of a 3D model of the whole mine, we can reorientate our vision and to integrate some circularity in the ore deposit at the beginning of the mine. And with this is something that we have tried to do, and we finish with this kind of models. And with this information, you can have really a detailed information of what is happening in the deposit and what you have, so you can orientate your applications. This is one example. We have taken this yellow marls here, and we tried to use it like a supplementary cementitious material. And the result is that from a laboratory scale, it works. We can use it to substitute clinker in the production of cement. And you know clinker now and cement is responsible for 8% of the global greenhouse gases emissions. So now a lot of efforts are done by the cement industry to decrease their greenhouse gas emissions. And this material showed that we can have a kind of a low carbon cement that we have here, using this pilot and then to get this kind of garden bench materials. It's really good and it works, and from a durability perspective, it's still there, and it's really a good one. The other thing, if we go to the other materials, if you go to what is already stored in the deposits, we got this kind of waste rock. And if we go into those waste rock, it's a mix of a lot of things at the same time. So what we have done, we have made a kind of a sorting of different materials that we have in those waste rock. And with this stock, we go out with flint, phosphate flint, endured phosphate, and so many other things. And this is a phosphate, and this one also is a phosphate. And we have made our own characterization and so on. We have found that there is still a lot of phosphate inside those things, and we have also many other things like aggregates and so on. So we have developed our own process based on an ore sorting machine, and in our case we have used TOMRA machine, and it works. And we succeeded to recover those phosphate that are in there, to have more resources of phosphate from the waste, but at the same time we are able to produce some other lithologies that will be used in the construction sector, for instance. The other thing is when we go to the process that produce those tailings, we have this process. This is what is happening right now. So what they are doing, they are only taking the phosphate, but they have a lot of tailings. So the idea here, why not going into another specific flow chart or another process where we can produce not only phosphate, we will have phosphate, but we can have also silica, and we can have also limestone at the same time with the same process. We will have just to change the outputs of the same process by changing molecules that are used in this process. Another example is with the coal. A coal company in Morocco, you know, the coal mining in Morocco stopped in 2000, but we produced a lot of waste, and you can see some examples here. So what we have done, we wanted to valorize it, and it's like extremely dangerous because it's really in the center of the city. And what we have tried, you can see here the dump, and here people are building our own houses just over there. So you can just imagine if there is like an earthquake or a lot of rain or something like that, you can imagine what will happen to this kind of waste rock dam. So what we have done, and we have taken those, we made our own drills company, we have like the 3D model of this, and what we have found is that we have coal still in there, and we have clays or shales in the form of shales. We have very high content of alumina, silica, and so on. And with this, we are able to produce bricks, really good quality bricks. With 100% of those materials, at the same time of bricks, we can produce also coal. And here, there is like, it's a coal thermal plant that is consuming imported coal in Morocco. Other case studies in the world, okay? And those are like startups. Circular Mine, what they are trying to do is like, what a future mine with storage facility could look like. For them, Circular Mine, we can go from a mine to produce our minerals and metals, but at the same time, we can be producers of aggregates and sand and so many other materials. And for them, it works already. You can visit it. It works. From mine waste, we can produce aggregates. The other one in Sweden, I really like this solution here. You got Boliden and LKAB. One is a producer of copper, and another one is a producer of iron, right? And both of them are producing waste rock and tailings. So what they have done, they have tried to collaborate. So they will use their resources and their tailings coming from each process. So they will not go only with iron and copper, but they can also produce with this process iron oxide, fertilizers, phosphoric acid, rare earth element, gypsum, fluoride products. And this is really a very nice project that is happening over there. The advantages of this collaboration is because we have two companies at the same place. The distance between them is not that high. We talk about 30, 40 kilometers between them. So they can build this symbiosis and synergy between them. And I really like this example. Another one is Bitolar in Finland. And in Bitolar, what they have done with Metso, they have tried to produce what they call, what is the name? It's a sand from the tailings. And they will use it to construct buildings with very low carbon footprint, using tailings of a mine, using the technology of Metso to build very nice buildings with very low carbon footprint. The other one is Travertine Tech. And this one is also is very nice. Why? They have the waste over here that is rich in sulfate, but what they are trying to do with their process, it's an integrated process. They take the sulfate waste and they try to fix and to mineralize the carbon oxide coming from the atmosphere or coming from the industry using renewable energy to produce what? Green hydrogen, carbonate minerals that can be used by many other sectors, and sulfuric acid. You know, it depends on the type of the waste that you have. But if you take this example of a waste that is rich in sulfate, like phosphogypsum, for instance, or you can take any example that you can have, phosphogypsum with all these things and with their process, you can produce your sulfuric acid that you are already consuming a lot in your process. And you can produce your own sulfuric acid to look for your metals and minerals like lithium, nickel, and phosphorus. And this is an example that is already have been developed. Those are the different case studies. And now, the challenges to do so, they are multiple. There are challenges in terms of technology that is there, that is needed also to develop these kind of solutions, economic challenges, knowledge gap. You know, when we talk about waste, no one knows what's inside exactly. What are the characteristics of the waste? What is the composition of the waste? What is the volume? What are the heavy metals in there and so on? And we don't know a lot about that. And in the mining sector, we know a lot about what we are producing, but we don't know a lot, or we don't know nothing about the waste. And a lot of effort for the metal and the minerals or the commodity, but the waste we don't know nothing. And here, this is why it is very important to know that waste, what are its characteristics, the composition, and so on, so you can deal with that. And we have also regulation. And when we talk about regulation, in some countries, like in Canada, for instance, they have incentives for each ton of waste that you are producing, you have to pay for that ton of waste. And they have even developed a kind of standard that you can use to valorize your tailings and waste rock. And there is a kind of guidelines that you have to follow to show that your waste is good and it can be consumed by any industry. We need a lot of innovations in terms of strategic planning processes. If we go into the first steps of the production or the production of the process production, we will need to change our planning of the production. We will have to produce, to secure our productions in terms of our metals and commodities, but we will have also to plan the waste and to design the waste. Once you want to design the waste, you will have also to plan it, because you will need a lot of infrastructures, equipment, machines to put them into the process so they will be used. So your production also will maybe like decrease a little bit, but this is something that you will have to deal with. We need a lot of business innovation also with the business or the example of Bolaiden and LKAB. There is a business already in there, and it works. We have other examples in different places also, and we are trying to do exactly the same thing in Morocco with the OCP group producing phosphate. But when we come into this, the business models that are used in this kind of businesses are not really enough developed. So there is also something that is needed in there, legal and regulation and so on. And depending on the nature of the waste, we can say if it's a material that can be used in the proximity or just next to you, or it's a material that can go beyond your location where you are, and it can like travel. It's the value of that thing that is very important in this level. So to finish, circular economy is not about one manufacturer changing one product. It's all about the interconnecting companies like LKAB and Bolaiden, for instance, that form our infrastructure and the economy coming together. It's about synergy. It's about rethinking the operating system itself. We have a fantastic opportunity to open new perspectives and new horizons instead of remaining trapped in the frustrations of the present. With creativity and innovation, we really can rethink and redesign our future. And with this, I would like to thank you for your attention. Thank you so much.